Hola, 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 hola. Hello, everyone. How have you been? I hope you're doing well. Ay, 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 ay. All right, let me check the gallery view. All right. Yeah, sorry. Please, anyone, please turn on the camera. Living graders.
Hi, Mister. Yes, in just a second.
Mhm. Thank you so much, Ivan. Um, thank you, Fernando. Thank you, David. Thank you, Chinchilla. Please, Salvador, Sofia, Agüero, Valeria, Victoria, and Lopez. Please turn on the camera, please, before to start the solving the classwork number 1. Okay. Today we're going to try to solving the classwork number 1. Okay, now how are we going to follow this order? Okay, the first of all, I'm going to solving the part number 2 to expand and combine the logarithmic expressions. After that, we're going to solve the problem number 1, and the last one, the problem number 3. So we're going to arrangement with the mechanical part first, and after that, the word prompts, the applications. Thank you so much for Ivan, Fernando, Ricardo, Victoria, Camila for turning on the camera. Please, the rest of the people, let's say it again. Please request one more time. Please turn on the camera. Thank you, Eduardo. Eduardo, quítese esa capucha, Eduardo.
Mister, estamos en la
Hola,
escuela.
mucho gusto.
Espérenos, mister.
Quítese esa capucha, Eduardo. Fuera capucha, que no es Altair, no es así inscrita cosa. Gracias. No, no, no quiero que vaya a poner a alguien ahí, requiere escache empate, ¿verdad? Bueno, all right. Well, it's going to begin, all right, with solving the classwork
¿Por
number
qué,
1.
mis?
Okay, so that's going to begin with the classwork number
Oye,
1
mis, hace
solution.
frío.
Okay, I'm going to start with the part number 2 first, and after that with the word problems, okay? Okay, in the part number 2, going to start with this one, after that with the word problems. In the part number 2 mentioned, we must to expand, expand or combine the following logarithmic expressions. Okay, we're going to begin with the first one. In the first one, the letter A, we have log base number 2, and we have the expression x multiplied by the square root of x squared plus 1. Okay, obviously in this operation, we have to expand these logarithmic expressions. So because we have a product, remember what the problem says. We must copy log A plus log B. But remember, a square root, we can read it like exponential for like a x squared plus 1 elevated the second power. In every expression who has singular power, it doesn't matter if we have positive, negative power, or fraction power, those powers passes to multiply the logarithmic expression. So for that reason, log base 2 x plus 1/2 log base 2 parentheses x squared plus 1. This is going to be the solution set from the first problem. Obviously, in this operation, we must expand the expression. Okay, so in the letter B, we got log parentheses 4x cubed over y squared parentheses x minus 1 fifth power. Okay, we have a division. So the first thing that we have to do is subtract the first one minus the second one, log y squared parentheses x minus 1 of the fifth power. Because we have a product, we have extension by addition. I mean log 4 plus log x cubed minus parentheses log y squared plus log x minus 1 fifth power. The powers passes to multiply every logarithmic expression. So we got log base 4 plus 3 log x. Negative times positive will be negative. Negative what? Twice log y. Negative times positive will be negative 5 log x minus 1. Okay. This is going to be the letter B, the second expansion. The letter C. The letter C. In the letter C, we got natural logarithmic or of is cubic root x4 power plus 12 over x plus 16 times square root x minus 3. Okay, we have to expand once again this expression. And remember, the roots can be written in exponential form. For example, in the first one, natural logarithmic of x4 power plus 12 elevated at 1/3. Subtracting natural logarithmic of x plus 16 times x minus 3 elevated at 1/2 power. Because we have a product over here, we can expand like addition, just like this one. Natural logarithmic of x4 power plus 12 1/3 minus brackets or parentheses as you wish. We got the natural logarithmic of x plus 16 plus a natural logarithmic of x minus 3 at a 1/2. Those parentheses. And finally, the powers passes to multiply every logarithmic expressions. So we got 1/3 natural logarithmic of x power 4 power plus 10 negative natural logarithmic of x plus 16 minus 1/2 natural logarithmic of x minus 3. Okay, and we have at least the first 3 expansions. So guys, do you have questions under this part or everything's clear? ¿Estamos claros hasta ahorita? ¿No hay preguntas? All right.
No,
Okie dokie then. So the first 3 expressions we're supposed to expand. Now the next 3 expressions we must to combine. Combine. That's why I decided to start to solve with this one because it's the longest part of the of the classwork. Okay, so the letter D. We have log base 5, number 5. No, sorry, log base 5, log 2. all right, plus log base 5, parentheses x plus 1, and subtracting 1/3 log 3x plus 7. So first of all, because we have addition, we can combine one single logarithm expression multiplying both terms. Log base 5 of what? Sorry. 2 times x and 2 times 1. The expression will be 2x plus 2. Subtracting, because we have this number multiplying the logarithm expression, passes to be a power. Log parentheses 3x plus 7 elevated to 1/3. Now, because both are subtracting, passes to divide. And the answer will be log base 5, if you wish brackets, 2x plus 2 over cubic root 3x plus 7. This is going to be the solution from the letter D. Okay, solution from the letter D. The letter E.
Sir,
Mhm.
one question. It's really properly to multiply 2 and x plus 1, so I just did like 2 parentheses x plus 1, like is it wrong?
No, it's a bad thing, but this is not complete. Remember, you have to combine to reduce. In this case, you don't need to simplify. You have to combine. When I said combine, you have to perform every operation as you wish. If you have, for example, 2 parentheses x plus 1, I'm not saying this is a wrong process, but it's incomplete because you have to combine every expression. That's why I'm doing that simple elementary process step by step. You're going to see just one example in the letter E. In the letter E, we have log x minus 2, x minus 2, plus log x plus 2, because basically the main idea is combining one singular logarithm. When we said combine, we have to reduce the expression, not factorize the expression. And negative 1/2 log x squared plus 4. For example, we have addition, right? So we can copy at least for a while the expression log x minus 2 x plus 2, all right? Subtracting this 1/2 has to be a power log of what? X squared plus 4 elevated than 1/2. Now, because both terms are subtracting, we can combine like a log or brackets x minus 2 x plus 2 over square root x squared plus 4. But we have to simplify this expression. We have to finish with this one. So x minus 2 x plus 2 is different square, a minus b, a plus b. So the real combination of this step will be given by x squared minus 4 over square root x squared plus 4. And this is going to be that solution set from the letter E. The letter E. If you see x minus 2, x plus 2, I'm not saying we have a grown process. This is a good process, but we must finish that process. We cannot live in that situation like incomplete method. We must finish as soon as we can, every step by step. All right. Questions to this part, or everything is clear? No questions? Okay.
Mister,
Uh-huh.
in the letter E,
Mm-hmm.
is that I have like the answer.
Mm-hmm.
I didn't put like I put like positive 1/2. I don't know
Remember
why.
what? Remember what did I tell you? I actually explained in the last class where every time that we have a roots, we have to pass the root into a powers, and when you have to combine the powers, it has to pass us the roots. Remember, you have to transform the powers into roots. This is a golden rule because the original ones had square roots, cubic roots, and so on. This is a golden rule always. We have to transform powers, the fraction powers to roots and roots and powers. Remember, I explained you that already in the last class. If you didn't think, for example, x plus 2, x minus 2 over x squared plus 4 elevated to 1/2, yeah, mathematically is the same, but it's incomplete. I'm not saying that we have the wrong answer, but you don't have the full answer because we have to summarize the process applying every properties. Just like example in the letter F. If you see in the letter F, we got a 1/2, 1/2, brackets, natural logarithm of x minus 4. Okay, plus 5 natural logarithmic of parentheses x squared plus 4x and close parentheses. Obviously, the first thing that we must do is the operation inside the parentheses. I'm going to copy once again 1/2, open brackets, natural logarithm x minus 4. This number 5 is multiplying, passes to be power. Natural logarithm of x squared plus 4x elevated at the 5th power. Now, these two terms are adding. We can combine like as one singular product. I mean, 1/2 natural logarithmic of what? X minus 4 parentheses x squared plus 4x at the 5th power. In this case, we cannot multiply this term because this parenthesis, this binomial is overprotected by the 5th power. So this 1/2, this multiplying passes to be the power. The power of what? Natural logarithm of x minus 4 parentheses x squared plus 4x close brackets elevated and the 1/2. What does that mean? That means this entire expression will be elevated at the one singular square root. So solution will be given by square root of x minus 4 parentheses x squared plus 4x. And this is the complete combination of the letter F into the natural logarithmic space. Oh, yeah, 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 yeah. Let me print screen. And let me send a picture into the WhatsApp group. May I erase the whiteboard or not yet? Okay. Questions? Anyone? ¿Nadie más tiene preguntas? ¿En casa nadie? ¿En Valle de Sula? ¿Hay alguien que tenga preguntas referente a la combinación y expansión?
You should see their faces.
Excuse me?
You should see their faces.
Okay.
Nobody wants to ask, but I don't think they're clear.
I think that everything is clear because no one is asking. Okay. I think so.
If you
All
ask
right.
me, I don't think it's clear. Do you have another example similar to that one that you can redo? Because Their
This
faces tell me it's not clear.
all right, this is we are so in this case, this is not one singular class. We are doing the solution set for the classwork. We made this lesson. We saw that one a couple of weeks ago. So and actually, it's not a one singular class to explain for every exercise. For another exercise, we're solving the exercise for the classwork. They're supposed to manage that one, but if you're having trouble, in the next class, we can prepare a review for the combined and expansion logarithm expressions. But we are explaining what is the solution set for the classwork. They developed yesterday. But
Okay,
remember, guys, if you really want to combine and expand logarithmic expressions, you must learn and memorize, just like the table, the number one, the rules of the logarithmics. Because if you not memorize the rules of the logarithmics, you're never going to expand, or you're never going to combine the expressions. It's the same thing with the students in the, I don't know, second, third grade. They really want to learn how to multiply. If you really want to know how to multiply, the first thing they have to learn or memorize are the multiplication tables, right? So same happens with the logarithmic. If you're not memorizing the rules of the logarithmics or their properties, that's impossible. You're going to solve that one. Okay. So that was the second part of the classwork number one solution. Now let's going to begin with the first part in the
Listen,
last.
before you raise the board, I do have a question. Where did the exponent on like
In what?
on the last one go, like the 5
In which one?
in F?
The black one. In which part?
There's like an exponent that says 5 and the x squared plus.
Well, this is what I'm
F.
saying. Remember the rules of the logarithm expression. If I have, for example, log base A elevated to n power, that will be equal n log base 8. This is what I'm talking about, the rule number 3. If you
Yes, I
see,
know,
every
I know
time that,
that.
well,
But where does it go when you move the like 1/2?
because I missed them.
Okay.
I missed the number 5, sorry. Thanks for letting me know. Thanks for
Okay.
letting me know. Me lo desayuné el número 5. All right. Remember the rules of the logarithm expressions are so crucial. All right. Now let's going to solve in the first part of the classwork. Remember, I'm not going to copy the entire word problem because you have already done in your notebooks, and actually you received that one in your classwork. So I'm going to read the word problem and provide the equation with the questions on the first word problem. Okay, in the first word problem, we have a one singular modeling equations. The modeling equations in the first word problem says we have a 50-gallon barrel is filled completely with pure water. Salt water with a concentration of 0.3 pounds per gallon is then pumped into the barrel, and the resulting a mixture that overflows at the same rate. So the amount of salt in the barrel of the time t is given by, this is the reported relevant equation. In the problem number 1, we have the function q dt equals, okay, 15 parentheses 1 minus e elevated the negative 0.04 t. All right, this is going to be a function, the given function in the first problem. In the problem is clarifying that t is measured in minutes. So t represents the times in minutes, and QDT represents the quantity of salt in pounds. Okay, this is what the problem says. Okay, so we have two questions. The first one, the question is letter A. How much salt, how much salt is in the barrel after 5 minutes? After 5 minutes. So what are you going to do? It's simple. I'm going to copy the model, but in this model, the only thing that I have to do is multiplying, I mean substitute the letter T by 5. So we're going to evaluate QT5 equals 15 parentheses 1 minus E negative 0.04 multiplied by 5. So in simple merely words, QT5 will be equal to 15 parentheses 1 minus E elevated at the negative 0.20. All right. So this answer will given by 2.72 pounds. We must use the calculator, and that's it. This is the solution set for the first question. How much salt is in the barrel after 5 minutes? In the second one, practically is the same because in the letter B mentioned how much salt is in the barrel after 10 minutes. So let's do it again. The same model, substitute by, but instead of 5 will be 10. We have 15 parentheses 1 minus E elevated to negative 0.04 multiplied by 10. So QT10, that will be given by 15 parentheses 1 minus E elevated to negative 0.4. All right, so that reason, the second question will be 4.95 pounds. All right, and the last one, the problem says, oh, okay. So in the letter C says, draw a graph of function. Okay, the graph of function. Remember the function is the black one, okay? So first of all, what we're going to do, we can manage the instead to set X and Y axis, in this case, we're going to call this one letter T and QT. With T represents period time and QT is represented by the pounds. So we can use numbers like a 0, 5, 10, 15, 20, and 25. When X equals 0, you know the answer will be 0. When X equals 5, the answer will be 2.72. When X equals 10, will be 4.95. When X equals 15, will be 6.77. When X equals 20, that will be 8.26. And finally, with this 25, that will be 9.48. So let's going to drop the function, the graph of the function. No big deal, no complicated things. All right. All right. 2, 4, 6, 8, 10, 12, 14. Remember, this is QDT represents pounds, and this is T representing in minutes. 5, 10, 15, 20, 25. Okay. So in the first one, 0 with 0 will be located over here. In the second one, 2.72 approaches over here. With 10, 4.95 approaches over here. 20, 8.26. 10, 15, no, 6.67 with 15 approaches over here. 20 with 8.26 approaches over here. And 25 with 9.48 approaches onto the number 10. So the graph will be increased in this behavior. This is the graph, the given graph in the problem number 1. Okay. That was the solution set for the part number 1, the first word problem. In the last one, I mean the part number 3, in the part number 3 is a problem gave us they're talking about the third case, right? Pavlo. So remember, in the last part with this the Newton's Cooley law is given by the following equation. TDT equals TS plus DO E negative KT. This is the model of Newton-Cooley's law. We're explaining the nature for this remote single logarithmic equation a few weeks ago. So let's going to read the problem. The problem says a roasted turkey is taken from the oven when its temperature has reaches about 185 degrees, and it's placed on the table in a room when the temperature is 75 degrees. So why is so useful this information? Because with this information, we can determine DO. DO will be the original temperature minus the temperature of their surroundings. So at the beginning, the problem says, okay, the initial temperature was 185 Fahrenheit degrees, and the temperature of the surroundings was 75 Fahrenheit degrees. For that reason, DO has a value of 110 Fahrenheit degrees. So we got the first step. We know what it is, the value from DO. The next step, that's supposed to be trying to find out what will be the constant K. So continue with the problem. If the temperature of the turkey is 150 Fahrenheit degrees, the new temperature is 150 Fahrenheit degrees. The question is, after half an hour, what is the temperature after 45 minutes? I mean, the new temperature after period of time 45 minutes. So before to asking or solving that question, what will be the temperature after 45 minutes, we really need to know what will be the constant of cooling in the Newton's law. So that's why before to establish the solution from the problem, that's going to looking for what will be the value from K. Before to answer the question T equals 45 minutes. For example, the temperature TDT in this case was 150 equals TS, remember the temperature of the surroundings will be 75 plus DO 110 E add the negative K, but remember T. What's happened with the letter T? In these circumstances, the letter T in this period of time says when it passes half an hour. Half an hour. So half hour. So that means 30 minutes. Half hour, that means 30 minutes. Remember the period of time that's supposed to give us in minutes. Okay, this is what we're talking about in this case. So we must subtract 150 minus 110 divided, oh sorry, minus 75 over 110. This is going to be equal to E at the K parenthesis negative 30. So subtracting both elements, we got 15 over 22. 15 over 22 equals E K parenthesis negative 30. Because we're looking for solving for T, all right, we're going to take the natural logarithmic in both sides. What happened? Natural logarithm of pi over 22 will be equal negative 30K. Natural logarithmic E, but remember, natural logarithmic E will be 1. So natural logarithmic of pi over 22 over negative 30, that will be the value from K. And that value of K, my dear students, will be given by 0.0128. So we have the K value. And because we have the K value, now we can write the function. I mean, TDT equals, instead to use TS, we're going to use 75 plus 110 E negative 0.0128 times T. We have the modeling function, the complete modeling function. Now it's time to answer the questions. The first one is, what will be the new temperature when it passes 45 minutes? So we have to evaluate T over the 45, that will be equal to 75 plus 110 E, the negative 0.0128 times 45. So the first answer, the answer in this situation will be 136.84 Fahrenheit degrees. That was the first solution set, the letter A. And the last one, the letter B mentioned, okay, when the temperature, the second question is when the temperature will cooling down to 100 Celsius, 100 Fahrenheit degrees. So if you wish, you can rewind once again the function DDT 75 plus 110 E negative 0.0128 T. Now they're asking for when it's cooling down to 100. So substituting this one, 100 equals 75 plus 110 E negative 0.0128 T. Adding passes to subtracting. And this is multiplying passes to divide. Negative 0.0128 T. 100 minus 75 divided by 110, we got 5 over 22. So that will be 5 over 22 equals E negative 0.0128 T. And because we're looking for the period time, both sides using natural logarithmic, what happened? This way, natural logarithm of 5 over 22. By the other hand, we got negative 0.0128 T. Remember, natural logarithm E will be 1, so those make sense. We can copy that situation, and let's going to solve like a natural logarithm of 5 over 22 divided by negative 0.0128. This is going to be, the value from t will be 115.75. And this is going to be minutes. And that is the solution set for the word problem number 3. What? We are over past 4 minutes. Why nobody tell me? ¿Por qué nadie me dijo? Nobody did tell me. Well, that was interesting in the class. Okay, so I took the picture to the WhatsApp group, and this is all the sorry. That was the entire classwork solution set. So questions, doubts, questions? No? Mhm.
Yo ayer le mandé el classwork al correo.
Okay, so, and I'm talking about questions about the solution for the classwork. And no questions, no doubts?
Right here. No, Eduardo says he's going to write to you because he had a little issue yesterday.
No, se lo mandé al correo.
He said he's working through the emails.
Okay, all right. Okay, okay, guys, thank you so much for the attendance. Have a great, wonderful day. Take care of yourself. See you on Monday, God wills. Take care of yourself. Bye-bye.
Thank you.
Salon, take care of yourself.